Okay. First of all, see one experiment. Okay. So we are going to take a flask with calcium chloride. Okay, and then I'm going to take one test tube, and in that I will take the sodium sulfate. The total weight of calcium chloride and the sodium sulfate is 300.23 grams. Okay, now next what I'm going to do that I'm just pour that sodium sulfate into the calcium chloride. Now see, there is a mixture of calcium chloride and sodium sulfate, and there is form precipitate of calcium sulfate. Okay, now check the weight. Now also weight is 300.23. Okay, so what is that is the law of chemical combination. Okay, this is the law of chemical combination. Okay, now just see some brief about it. See, first of all, in that the law of conservation of matter. Now see what is this. In a chemical reaction, the total mass of reactant is the same as the total mass of product formed due to the chemical reaction, and this is called the law of conservation of matter. Now see students, what happens? In the previous experiment, we have taken calcium chloride and sodium sulfate. Okay, just a second. Next. Sorry students, just there is a net problem. I'm again sharing the screen. So in the experiment we have seen that there is calcium chloride is there, okay, and sodium sulfate is there. Okay, we have taken them separate and measure their weight. The weight was 300.23 grams. Next, what we have done? We just pour that sodium sulfate into the calcium chloride, and there is calcium sulfate. What that precipitate of calcium sulfate was formed, and after that also, the weight is same. Okay, so this is called as law of conservation of matter. Okay, after reaction also the weight is same. Next one is law of constant proportion. Now law of constant proportion means what? The proportion by the mass of the constituent element in the different samples of the compound is fixed. Now see, what is that? All of you know the formula of water. The formula of water is H2O. It means it requires two elements of hydrogen and one element of oxygen. So 2:1 is the ratio. This is the constant proportion. This one is the constant proportion. Okay. In the carbon dioxide, CO2, it means one element of carbon, one atom of carbon and two atom of oxygen. So proportion is 1:2. It should be constant. After that only the new substance will be formed. Now for that we have seen this chemical law. Okay, so just see this clip, you will understood very well.
When two chemicals react with each other, they form new substances. The composition of substance changes during chemical change. Scientists studied these reactions and stated some laws of chemical combination. First one, law of conservation of matter. In a chemical reaction, the total weight of the reactants is same as the total weight of the products formed due to chemical reactions. Example, reactants are copper sulfate and sodium hydroxide. The total mass of the reactants is 60 gram, and after completion of the reaction, copper hydroxide and sodium sulfate will form. The total mass of the products will be 60 gram. It means there is no loss or gain of mass during chemical reaction. Second, law of constant proportion. To understand this law, first we have to revise how compound is formed. When two or more elements combine or react chemically with each other, new substance will be formed. Mostly they have totally different properties than the constituent elements. For the formation of new compounds, we have to understand certain rules. Suppose we want to prepare carbon dioxide from carbon and oxygen. Then we will have to take 12 gram of carbon and 32 gram of oxygen. We cannot add two elements in any proportion we want. The proportion by weight of carbon to oxygen while making carbon dioxide should always be 3:8. The law states that the proportion by weight of the constituent element in the various samples of the compound is fixed. This law was stated by French scientist J. L. Proust. One more important thing which we have to understand is that though the source of the compound is different, the proportion of the constituent elements is always fixed. Suppose someone getting water from different sources as a product of different reactions. Even then, the proportion by weight of hydrogen to oxygen in water is always 1:8.
Hello? Am I audible? Hello? Students, keep quiet. Oh. हॅलो. बरं, एक मिनिट सर. सर आता आवाज येतोय का? हॅलो. हॅलो मॅम. मॅम आवाज येतोय का? हॅलो. हॅलो, आता येतोय का मॅम? हॅलो. हॅलो मॅम. खूप कमी आवाज येतोय. बरं, एक मिनिट. हॅलो मॅम, आता येतोय का? हॅलो. हॅलो मॅम, आता आवाज येतोय का? हॅलो, हा येतोय का मॅम आता आवाज? हॅलो. हॅलो. जाधव सर. आता येतोय का मॅम? हॅलो. 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 आता येतोय का सर? हॅलो. हॅलो सर. काय? Okay, see. Next topic is molecular mass. Okay, students. So molecular mass of a substance is the sum of atomic mass masses of all the atoms in a single molecule of that substance. Now see. Just a second. Okay. So student, listen. First of all, what is the molecular mass? Molecular mass means the number of atoms in the given chemical formula, okay, and the atomic mass of each element. Okay. Now let us find the molecular mass of
molecular mass of substance is equal to sum of constituent atomic masses. Okay, now find out. See, molecular mass of H2SO4 is equal to, see, first of all, we'll write the formula. See, atomic mass of hydrogen. How many elements of atoms of hydrogen? Two. Support two. Service students, due to mobile problem, it is not seen properly. Okay. Then add atomic mass of sulfur into iron atoms and one atom support one. Okay. Again, plus add atomic mass of oxygen. How many atoms are there? Four atoms are there. So into four. Now see, atomic mass of hydrogen is 1. Okay, so 1 into 2. Okay, plus atomic mass of sulfur is 32 into 1. Okay, plus atomic mass of oxygen is 60 into 1. Okay, now see, 1 into 2 plus 32 into 1, 32. Total addition is 90. So molecular mass of H2SO4 is 98. Okay, it is very easy to find out. Okay, just you know the atomic mass of that element and number of elements or number of atoms already given. So you know about only the atomic mass of that element. Now let us find another. You will tell me. Molecular mass of HNO3. Okay, so we go through the formula. Molecular mass of H2SO4. My mistake is there. So atomic mass of hydrogen. Okay, how many elements there? Only one. So one. Okay, plus. Then next one is the nitrogen. Okay, so atomic mass of N. How many elements are there? How many atoms are there? One. So one. Again, oxygen. Atomic mass of oxygen into how many atoms are there? Three. So multiply by. Okay, let us multiply by. So atomic mass of hydrogen is 1. Element is also 1. Atomic mass of hydrogen is 1. Element is also atomic mass of nitrogen. It is 14. Into 1. It is okay. Again plus atomic mass of okay. Let's take atomic mass is equal to 1 on the 1 into 14 on the 14 plus 16 on the 14 and the total answer is 60. So this is the molecular mass of H10O.
So this is the molecular mass of H10O.
So it is very simple.
Okay. So it is very simple,
Students.
Okay. Are you getting, students?
Yes, students.
Yes, sir. Yes, students.
Now, next concept.
Now, mole. Next concept is mole. So, what do you mean by mole? Mole means 1 mole of compound is the mass of substance in grams equal to negative to its molecular mass. And the SI unit is mole. That is MO. Number of moles is
Grams. Okay, how many grams?
okay, how many grams gram in a given chemical compound.
So,
Okay.
this formula is
number of moles of
the mass in grams. Okay, and molecular mass. So molecular mass.
So molecular mass.
This you know that
how to calculate it.
Mass of the gram. Mass of element. Mass of substance in a gram. It will be given. So let us solve one example. Okay. Before going to solve the example, we must know about the Avogadro. Okay, system.
Okay, sister.
Everyone there is kg.
You know,
So 1000 gram is equal to 1 kg. Okay.
so 1000 grams. Some 1000 grams.
So like that, mole has also
So like that,
specific
mole
value.
has also
Okay. And this value was found out by Avogadro, the scientist Avogadro. So the unit given is the constant value, and this constant value is called as the Avogadro. Why? Because it is found out by the Avogadro. So this value is called as the Avogadro number, and its value is 6.022 into 10 raised to 20. This is the constant value. Okay. By using this, we are going to find out the solution now.
Going to solve the example
So,
now.
how many molecules are there in 6 gram of carbon dioxide?
Carbon dioxide.
Go go through the formula.
Go through the
Simple.
formula.
Okay.
Simple.
Now,
Okay. Now,
number of moles
number of
given
moles
CO2 is
given
equal
in
to. Okay. First of all,
okay, first of all,
mass of substance
mass
in
of
grams. So
substance in
gram
grams.
they have
So
already
grams
given,
they have
that is
already given,
66.
that is 66.
Okay. And molecular
Okay,
mass of the
molecular
substance
mass of
is
a substance
42. How it is?
42. How
See,
it is?
CO2. How to
CO2.
find out the
How to
molecular
find out
mass?
the
So
molecular mass? So what
atomic mass of carbon
atomic
is
mass of
12
carbon
into
is
how many
12
elements?
into how
1
many elements?
plus
1 plus
oxygen. What is the
oxygen.
atomic mass?
What is the
16.
atomic
How
mass?
many elements?
16. How
2.
many elements?
So add
2.
them. 12
So
into
add them
12
12
plus
into
6
12
into the
plus 6
32.
into
It will be 44. So molecular mass will be
molecular mass will
44.
become 44.
Now
Now
66 divided by
66
44
divided by
is
44 is
1.5. It is
1. It is
1.5.
1.5.
But we have to
But we
multiply
have
with
to
the
multiply
Avogadro's
with the
number. Why?
Avogadro's
Because
number. Why?
it is the
Because it is the
main value.
main
It is the
value.
unit of
It is the unit
the
of the
that is why
mole. That is why 1.5 into
6.022
into
now
20.
multiply
Now
them. What
multiply
is
them.
your answer?
What is your
The
answer?
answer will be
The answer will be
9.033 into 10 raised to 20.
10 raised to 20.
So it is very easy
It
to
is
find
very
out.
easy to
Okay.
find out.
You must know that
You must
how
know
to
that
find out the
how to
molecular
find out the
mass, and
molecular
it is
mass,
also
and
very
it is
easy.
also very easy.
So let us find
So let
another
us
one.
find another one.
So
So
how many molecules
how
are
many
there in a
molecules are there
36
in
gram
a
of
36 gram
H2O?
of
Okay.
H2O?
So let us
Okay.
find.
So let us find.
This is the formula.
This is the formula.
Okay. Just so mass. How
So
much mass given?
how much mass
36
given?
and
36.
molecular mass
And
of
molecular
H2O
mass of H2O is
18. Now see,
now
it is
H2O
H2O is equal to
is
1 into
how many atoms? 2. So 1 into 2 plus oxygen. There is only 1. So 16 ones are 16.
now 1 twos are 1
And into 16 ones are 16. So 2 plus 16 is 18. So 36 divided by 2. Go to the next. 36 divided by 18 is 18 twos are 36. Multiply with the Avogadro's number. Okay. So after multiplying with the Avogadro's number, the total number of moles are 12.044 into 10 raised to 23 molecules. Okay. All of you understood, students, how to find out the molecules? Yes, students. Or shall I explain once again? Okay, anyone? Students, have you understood or not? Okay. Okay. So, student, your assignment is find out the molecular masses of the following compounds. Okay, I have given the five compounds, that is H2O, MgCl2, KNO3, AgCl3, and MgO. Okay, if you want to find out the molecular, if you want the atomic mass, so it is given in the chapter number 4. Okay, count in your book, science book, chapter number 4. In that they have given atomic masses. By using that atomic masses, you can find out the molecular mass of the given substance. Okay, so thank you all the students to listen carefully. Okay. Ma'am, shall I?